Welcome to Unit 5, Analysis of Quadratic, Exponential, and Logarithmic Functions. We're going to start off with a warm-up today. So you will definitely need to have your own device or iPad, which you should be on right now looking at the video, or your phone. And the first thing I want you to do is I want you to go to this site, see it listed below, and do problems 5, 6, and 9 right here. And then go to the second site and do these problems 1, 3, 5, 6, 8, and 10. You can put your answers on a whiteboard, or you can write it in your notebook on a sheet of paper and turn it in. It's review things on quadratics. All right, let's get into our notes for today. We're going to be talking about domain and range, which was first introduced in Algebra 1. We're going to review our interval notation, which is in a previous booklet. Here's our symbol for the union. Again, our symbol for the intersection. This is what we use when we have closed circles, which means the solutions are included in the answer. And this is what we use when we have open circles, when the solution is not included. We talked about negative infinity, far, far, far left values on the x-axis, or could be on the y-axis down, and far, far, far to the right on the x-axis. So when we take a look at our very first question, we have this, which is called set notation. We have our curly brackets, and it reads y such that y is between 2 and 7. We write that in interval notation. What are we doing? We're starting at 2, which is open, and we're going to 7, which is closed, because 7 is a part of the solution and 2 isn't. So it's values that are greater than 2 all the way up to 7. Here are set notation, x values such that all the x values are less than or equal to 1. So if they are less than 1, they would start left to right. Far left on the number line is negative infinity, and it would go up to 1. Here's a review of interval notation. So we introduce to you how to find the domain and range. We want to make sure we pay attention to the arrows in our graph. So take a look here at this quadratic. We have an arrow here, which means the pattern continues. It goes on and on and on. So what we're going to do is we're going to find the domain and range. All right. So here we go. The domain, this is all real numbers. The domain we measure against the x-axis. And if you take a look, we see that we have these arrows that continue and continue and continue. So the pattern continues. So take a look at this. It keeps going to the left and it keeps going to the right. So therefore the domain is all real numbers. If we did that in interval notation, take a look. That's negative infinity to positive infinity. The range will be the y values. We're going to measure the y values according to the y-axis. So we can see that the arrows go up, so it continues to go up, which is positive infinity. However, this is my smallest y value right here, and that y value is negative 6. So the range is y values greater than negative 6. Y values greater than or equal to, let me not forget that. If I want to put it in interval notation, close bracket, negative 6, comma to positive infinity. Infinity will always have an open bracket. Well, take a look at this. Take a look at your arrows. You always want to make sure you know the direction your arrows are going. All the arrows are pointing to the right, so they continue to the right, but not to the left. So the domain, x values are greater than negative 4, because on my x-axis, which is where I measure the domain, here is where my x values start, right here at negative 4, and they keep going. Interval notation would be from negative 4 to infinity. Negative 4 would be closed, infinity would be open. Let's take a look at the range. We measure the range on the y-axis. So we want to check out the arrows. These arrows will continue and continue and go down. This arrow will continue and continue and go up. So they're not bounded, so it's all real numbers. Here's another way to write all real numbers. Negative infinity to positive infinity. Alrighty. So here is the graph of function. Is this a function? So we want to do our vertical line test, and we find out that it is a function. The question is the inverse a function? We do a horizontal line test, and we find out, yes, the inverse is a function. What is the domain? What are the x values that make this function true? Well, we look at our x-axis when we talk about domain, and here, this is where this function starts, here at -2, and it continues to go on to the right. How do we know? Because we have an arrow. So the domain, x value is greater than -2. Take a look at the range, and anytime you talk about range, look at the y-axis. This y-axis here, this is where my y values start, okay? And they are all going down. So my range is going to be y values that are less than 3. Y less than 3, 1, 2, 3. Here at 3, it's an open circle. So it's y is less than 3, definitely not equal to 3. All right, so we can say the range is negative infinity up to 3. Let's take a look at the next one. Is the graph shown a function during my vertical line test? And the answer is yes. We do a horizontal line test for the inverse, so that answer would be no. For the domain, we definitely want to look at our x-axis, and we see that the arrows show that this keeps going this way, and this one keeps going to the right. So what would the domain be? All real numbers, or we could write it as negative infinity to positive infinity. Let's take a look at our y values. The only y value here is right here at 3. So y is equal to 3. There are no other y values that make up this function. Let's take a look at this last one. This one, is this graph a function? Well, when I do my vertical line test, do I cross this graph more than once? And the answer is I do. So that means the graph is not a function. Let's take a look at the inverse, and we're going to do our horizontal line test. And we find out that it passes the horizontal line test, so the inverse is yes, a function. Domain, we look at according to the x-axis. So when I look at my points, arrows to the left, they keep going. My arrows to the right, they keep going. Are there any restrictions in the domain? No. All real numbers, or we can say it goes from negative infinity to positive infinity. Take a look at the range. The range we measure against the y-axis. We always want to locate our arrows and see what they're doing. These continue to go down. Let's take a look at this arrow, and they go up. So are there any restrictions on the range? No, it's all real numbers, and it goes from negative infinity to positive infinity. So that concludes our lesson on domain and range. We will be using domain and range throughout the entire unit, so we introduce it to you first. Thank you.